Welcome. My name is Miss Gooden, and the topic that will be discussed today is global water resources. Today I'll be helping you gain knowledge of water resources while working on techniques for reading and interpreting graphs. Lesson objectives. We need to utilize methods for reading and interpreting graphs and pie charts in environmental science. In environmental science, we use a lot of visual means of gathering information, and we want to make sure that you understand how to use those and why they're important. We also need to understand the distribution of percentages of fresh water versus salt water on our beautiful planet Earth. The last objective is to analyze some problems affecting global water resources. Pie charts and bar graphs. Why should we learn about pie charts and bar graphs? You've probably seen them before, but I want to kind of explain why they're so important to use. They actually make it easier to interpret complex data sets when you represent data graphically. If we have to take a bunch of numbers and just put them on a sheet or randomly, we don't understand them as well as we do if we put them in an actual organized chart or graph. Graphs are important because they can make trends and patterns more clear, so we can take information that's happening today and kind of see what may happen in the future. Pie charts are representations that make it easy to compare proportions, so we can do this with a very large amount of data and still have a very simplistic chart to look at to understand what's happening. Bar graphs use rectangular bars, horizontal or vertical, to show how large each of the values are, and this allows us to compare data. Here's our first pie chart. This is of the world water distribution. The first pie chart here is showing salt water versus fresh water. So out of 100%, 98% of the salt water is 98% of the water that's available is salt water. And then that leaves 2% for fresh water. So although the planet's called Earth, I always thought it should be called ocean because it's 70% ocean. And there is very little fresh water that is available to us. Groundwater is the second largest available. You'll see that here at 12%. The majority actually is locked up in ice. 87% is ice. So this little miniature pie chart is showing you out of the 2%. So this was 100%, and then out of this 2% of fresh water, this is showing you what is available out of the 2%. Where is it located? Ice is 87, ground 12, and then rivers and lakes approximately 1%. This is another chart that's showing you where is Earth's water. It's just done a little differently. This is a chart, it's a bar graph. So down here at the bottom is showing us this one is for total global water. This one is just for fresh, and then this one is for surface water and other fresh water. So when we look at the total, it kind of goes back to that very first pie chart we just seen, that this says ocean is around 97%, and then fresh water is around 2.5%. But then if we look at fresh water, again, most of it is trapped in ice, and that leaves only 30% for groundwater and 1.2% that's actual surface or other types of fresh water. Last is surface water and other, again, ice, and then lakes. Now notice the 0.49% that is on the river. This is a surface freshwater. And it sounds like such a very small amount because 0.5% out of all the water that's available. But rivers is where humans get the majority and a very large portion of their water from. So it's kind of amazing that only 0.25% does all that for us. Do we have enough fresh water? Now that you've seen the statistics of how much is actually available to us, is it enough? Well, the water cycle on Earth is actually a closed system. So that means that we can't add water, nor can we take it away. So we're always going to have the same amount. However, because our population of humans is growing rapidly, this puts more pressure on the water supply. So our demand is increasing. and the amount of water that we have, even though the actual amount is the same, it's actually effectively being reduced because of pollution and contamination and misuse of our water resources. So will we face severe water shortage? Well, some believe that the freshwater will be what we call a critical limiting factor in the near future. And limiting factors are things that can actually cause a population to stop increasing or actually cause it to decrease. And already about 1/3 of the world's population currently live in areas where they already understand what it's like to have water stress and water shortage. Some examples of that is in Asia. In between the years of 1955 and 1990, there's a 50% decrease in the amount of available water. So the projections say that by 2025, many countries in Asia will have severe water shortages. And just as a side note too, Africa has historically been known to be water poor. In fact, they spend more time, on average, getting water in some areas than they do have time to actually work, because it's such a big deal to go get fresh water. They may walk miles and miles just to get it. And this is another bar graph for us to analyze. This one is based on per capita water use. So over here is what we call a legend, and this is color-coded so that we know which continent is being represented in this bar graph. So this is telling us up the side here, this is the y-axis, meters cubed. So how much water use per continent in meters cubed. So we can see very quickly using this bar graph that North and Central America use the most, followed by Europe, and then the least is Africa. Now another quick fact is that the average American uses 147 gallons per day, whereas most other countries, not more than 40 gallons per day. So we definitely are water hogs. Breakdown of freshwater use. This is a pie chart, and this is utilizing colors to show us what is the use of the fresh water that we have available to us. And we use 70% of our use of it is for irrigation. This is for farming purposes because the plants need water and we have to have a way to get that water to them. So that is called irrigation. Only 8% is used for domestic use, brushing your teeth, taking a shower, flushing the toilet, and then 22% is industries that are using water to make products and things like that. So it is surprising to many that growing food uses more water than all other human uses combined. It's a surprising fact. So although it is a great idea to turn the water off while you're brushing your teeth and take shorter showers, and little common solutions that you've heard to help with our fresh water, our biggest use is actually in the farming industry. So how do humans affect water resources? Well, water resources face a host of serious threats, and most of them are caused by human activity. They include, but not limited to, pollution, which is contamination of our natural resources, urban growth, and deforestation, which is a process of removing trees in order to be able to build or use it for farmland. So each of these has its own specific impact. They usually directly affect the ecosystem and in turn affect the water resource. And an ecosystem is an area that is living and non-living that is interacting in the same environment. So when everything is connected, in turn that water resource is going to be negatively impacted as well. Pollution. Pollutants that harm water resources include things like organic matter, disease, causing organisms from human waste, from farm animal waste, fertilizers that are used to help the plants grow, pesticides that are help to keep the bugs off the plants. All of these things have a tendency of becoming into the water system. The other is acid rain, and this is a result of air pollution. So smog and things put things in the air, and then we have a problem with acid rain that also affects our water negatively. And then heavy metals. These are accidentally put into our water system because of a lot of the mining and industrial activities that we do. Urban growth. Because our populations are increasing, we need more food, so therefore there is more farming and more forest clearing, deforestation, for the purposes of building homes, Walgreens, Walmarts. Some places it's just a matter of clearing the land for more farming and road building to get into the places, and mining so that we can get to sort resources that we have underground. But by doing these things, rocks and small bits of soil end up in the water system that normally wouldn't be there, and this causes a negative impact on our water quality. And a quick fact here, the daily drinking water requirement for a person is 1.5 to 1 gallons, but it actually takes 528 to 1,320 gallons to produce just one person's daily food. So there again, making the point that most of our water is used for making, for growing and making our food that we eat. So just to recap, so today we did learn about global water resources. We used bar graphs and pie charts in environmental science and looked at ways to interpret them and why they're important to use. And then we also discussed the distribution of percentages of fresh water versus salt water. And now you know that we have only 2% of our water on the planet is actually dedicated to fresh water instead of salt water. And then last, we have problems that affect global water resources. There are many problems, and we did touch base on a few, such as pollutants and deforestation. Next lesson, we will focus on freshwater shortage solutions. Since now we know that there's a problem with it, what can we do about it? Additional resources that I have available for you are on these following links. If there's any key terms or vocabulary, you may look them up on this link here, as well as a transcript of this lesson, which is what I have said to you. And then there's a quiz/study guide. I do these different depending on the lesson, but it may include questions for you to ponder. It may be a multiple choice or a true and false little quiz for you, or it may just be a study guide to go over to help you recap and recall the information of today's lesson. So I'm Miss Gooden, and I appreciate your time, and I will see you, or you will see me, in the future.